In today's lesson, we'll be looking at the primary trigonometric ratios, also known as SOH CAH TOA. If you recall, SOH CAH TOA is a mnemonic which helps you remember these three primary trigonometric ratios. Sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. It is important to remember that the hypotenuse is always in the same position. It is the longest side and is located across the 90-degree angle, which is indicated by this square. However, the terms opposite and adjacent are relative terms. It depends on which angle you're taking the point of view of. So over here, this would be considered adjacent to theta. That would be opposite to theta. And over here, this would be considered adjacent to theta, and this would be considered opposite to theta. So again, these are two identical triangles, but they are labeled differently depending on which point of view you take. In our first example, we want to find the length of x to the nearest tenth. The first thing you want to do is label the diagram. This angle is 43 degrees. We're going to relabel that as theta. This side is 3 meters, and it is adjacent to theta. Meanwhile, this side, which is labeled x, is opposite to theta. The trig ratio that contains opposite and adjacent is tan theta. So I'm going to write tan theta is equal to opposite over adjacent. Next, I'm going to substitute in my known value. So instead of writing theta, I'm going to write 43 degrees. And instead of writing opposite, I'm going to write x. Instead of writing adjacent, I'm going to write 3. Next, you want to take tan of 43 degrees and put it into your scientific calculator. And you're going to get a number which is approximately equal to 0.93. Everything on the right stays exactly the same. At this point, you want to change 0.93 into a fraction. You can do that by simply putting it over 1. Next, we're going to cross multiply, which means we're going to multiply numbers which are across from one another. So that's going to give me 0.93 multiplied by 3 and 1 multiplied by x. Let's punch 0.93 times 3 into a calculator. That should give you 2.79. And over on the right, 1 times x is just x, because anything multiplied by 1 is equal to itself. Let's write a concluding sentence. Therefore, x is 2.8 meters. Remember, you want to round it to the nearest tenth. In our second example, we want to find the length of AC to the nearest tenth. AC is right over here, and I'm going to give it a variable of x. The first thing you want to do is label your diagram. We've been given this angle, which is 38 degrees. I'm going to label that theta. This side, which is 12 centimeters, is opposite to theta. And this side is the hypotenuse. The trig ratio that contains opposite and hypotenuse is sine theta. So I'm going to write sine theta is equal to opposite over hypotenuse. Next, I'm going to substitute in my known value. So instead of writing theta, I'm going to write 38 degrees. And instead of writing opposite, I'm going to write 12. And instead of writing hypotenuse, I'm going to write x. What you want to do now is punch sine of 38 degrees into your scientific calculator, and you should get approximately 0.62. Everything else on the right should stay the same, so that'd be 12 over x. At this point, you want to change 0.62 into a fraction. And you do that by putting it over 1. Next, we're going to cross multiply. And that is going to give us 0.62 multiplied by x, which is equal to 1 times 12. Let's simplify this a little bit. So over on the right, I'm going to take 1 and multiply it by 12. Remember, anything multiplied by 1 stays the same. Remember, you want to isolate x. You want it all by itself, but right now it is stuck with 0.62. So we need to do the opposite. So the opposite of multiplying by 0.62 is dividing by 0.62. And you got to do that to both sides of the equation. This cancels out, and you're left with an x, and you need to take 12 and divide it by 0.62 in your calculator. That is going to be equal to approximately 19.4. Let's write a concluding statement. Therefore, x is about 19.4 centimeters. In our third example, we want to find the length of y to the nearest tenth. First thing you want to do is find the angle, which is 54 degrees. We're going to relabel that as theta. That would mean the side labeled 28 meters is the hypotenuse, and the side labeled y would be opposite to theta. The trig ratio that contains both opposite and hypotenuse would be sine theta. So let's write that down. Sine theta is equal to opposite over hypotenuse. Next, we're going to substitute in our known values. So instead of theta, I'm going to put 54 degrees. Instead of opposite, I'm going to put y. And instead of hypotenuse, I'm going to write 28. On your scientific calculator, you need to enter sine of 54 degrees, and that should give you approximately 0.81. Everything on the right is going to stay the same. We want to change 0.81 into a fraction, so I'm just going to put it over 1. Next, we're going to cross multiply, which is going to leave us 0.81 multiplied by 28, and 1 multiplied by y. You can take 0.81 times 28 and put that into your calculator, and you're going to get 22.68. Now, on the right side, 1 times y is just y, because anything multiplied by 1 stays the same. Let's make a concluding statement. Therefore, y is 22.7 meters. I've just rounded it to the nearest tenth. In our fourth example, we want to find the length of k to the nearest tenth. First thing you want to do is label your diagram. This angle is 41 degrees. I'm going to relabel it theta. That would mean the side labeled k is adjacent to theta, and the side labeled 8.7 millimeters would be opposite to theta. The trig ratio, which contains opposite and adjacent, is tan theta. So let's write tan theta is equal to opposite over adjacent. Next, we want to substitute in our known value. So instead of writing theta, I'm going to write 41 degrees. And instead of writing opposite, I'm going to write 8.7. And instead of writing adjacent, I'm going to write k. You're going to take your scientific calculator and input the tan of 41 degrees, and you should get approximately 0.87. Everything on the right is going to stay the same. We want to change 0.87 into a fraction, so I'm just going to put it over 1. Next, I'm going to cross multiply. So I'm going to get 0.87 multiplied by k, which is equal to 1 times 8.7. Let's simplify some of this. So on the right, anything multiplied by 1 stays the same. So 1 times 8.7 is 8.7. Remember, you want to isolate k. You want it all by itself, but it's not by itself. It is stuck with 0.87. To get rid of it, you need to do the opposite operation. So instead of multiplying by 0.87, you're going to divide by 0.87. But what you do to one side, you must do to both sides of the equation. So those cancel out, and you're left with 8.7 divided by 0.87. And that's going to be equal to 10. So let's write a concluding statement. Therefore, k is 10 millimeters. In our fifth example, we want to find the length of y to the nearest tenth. First thing you want to do is label your diagram. We've been given that angle, so let's label it as theta. The side labeled 3.8 meters would be adjacent to theta, and the side labeled y would be opposite to theta. And the trig ratio, which contains opposite and adjacent, is tan theta. Next, you want to substitute in your known value. So instead of writing theta, I'm going to write 15 degrees. Instead of writing opposite, I'm going to write y. Instead of writing adjacent, I'm going to write 3.8. Next, you want to input tan of 15 degrees into your scientific calculator, and you should get an answer that is approximately 0.27. Everything on the right stays exactly the same. We want to change 0.27 into a fraction, so I'm going to put it over 1, which allows us to cross multiply. So I'm going to get 0.27 multiplied by 3.8 and 1 multiplied by y. I'm going to take a look at the left side of the equation. 0.27 times 3.8 is approximately 1.026. And 1 times y is just y, because anything multiplied by 1 stays the same. So I'm going to write a concluding statement. Therefore, y is 1.0 meters. I'm rounding that to the nearest tenth. In our sixth example, we want to find the length of x to the nearest tenth. The first thing you want to do is label your diagram. That angle is 71 degrees, which means the side labeled x would be adjacent to our angle, which we call theta, and 114 millimeters would be considered the hypotenuse, since it is the longest side and it is across the 90-degree angle. We need to figure out which trig ratio contains adjacent and hypotenuse, and that trig ratio is cos theta, which is equal to adjacent over hypotenuse. Next, we want to substitute in our known values. Instead of writing theta, we are going to write in 71 degrees. And instead of writing adjacent, we're going to write x. Instead of hypotenuse, 114. You're going to put the cos of 71 degrees into your scientific calculator, and you should get approximately 0.33. Everything else on the right stays exactly the same. We're going to change 0.33 into a fraction by putting it over 1, which allows us to cross multiply. So I'm going to get 0.33 multiplied by 114 and 1 multiplied by x. I'm going to deal with the left side first. So 0.33 times 114 is equal to 37.62. And 1 times x is just x, because anything multiplied by 1 stays the same. So let's write a therefore statement. Therefore, x is 37.6 millimeters. In our last example, we want to find the length of x to the nearest tenth. The first thing you want to do is label your diagram. This angle is 25 degrees. I'm going to call it theta. The side labeled 13 centimeters is the hypotenuse, since it is the longest side and it is across the 90-degree angle. This side labeled x is the opposite side. The trig ratio that contains opposite and hypotenuse would be sine theta. Next, we want to substitute in our known value. So instead of writing theta, I'm going to write 25 degrees. Instead of writing opposite, I'm going to write x. Instead of hypotenuse, I'm going to write 13. Using your scientific calculator, you'll figure out that the sine of 25 degrees is 0.42. Everything on the right stays the same. Next, I'm going to change 0.42 into a fraction. I'm just going to put it over 1, which allows me to cross multiply. So I'm going to have 0.42 multiplied by 13, which is equal to 1 times x. I'm going to deal with the numbers on the left first. So 0.42 times 13 is 5.46, and 1 times x is just x, because anything multiplied by 1 stays the same. Therefore, x is 5.5 centimeters.